In our previous lesson, we talked about greatest common factors and how to find greatest common factors. Next, recall the distributive property. A times B plus C. The distributive property says if we have something being multiplied to a quantity that's being added or subtracted, then we can distribute the outside multiplied number to each of the terms inside the parentheses. So we have A times B plus A times C. Notice with the distributive property, we're looking at two different operations, multiplication and addition, or multiplication and subtraction. We're distributing the higher operation, multiplication, over the lower operation, addition or subtraction. This will become a common theme as we go throughout the semester, where we'll learn other distributive properties. But, back on point, to factor out a greatest common factor, we actually use the distributive property in reverse. Instead of starting on this left side and going across to the right to actually distribute the value that's being multiplied, we notice in this expression, both of the terms have an A in it, so we're going to do that distributive property in reverse. So we factor out the A, and we're left with B plus C. That's factoring out a greatest common factor. And factoring out a greatest common factor is the very first step when you are factoring polynomials. You always look for a greatest common factor with all the terms first. So we're going to write an intermediate step in the factorization, and that intermediate step is shown in the example in the middle. Some of you are pretty savvy with your numbers and you have a pretty good grasp of them, and so it's okay if you skip that step as long as you are confident with using the distributive property in reverse. If you need to write it out, write it out. There's nothing wrong with showing more work, showing all your steps, taking notes when you're a little shaky on things. So, to factor the following polynomials, we're going to find the greatest common factor first, write each term as the product of the greatest common factor and the other factors, and then use that distributive property in reverse to factor out the greatest common factor. So we'll take this first one, 15x minus 15. I see that this could be 15 times x. I see the greatest common factor is 15. Minus 15 times, well, I need something. I can't just leave it as 15. So I'm going to use times 1, the identity. 15 times 1 is 15. I'm not changing the problem by introducing a 1 to multiply. And so we'll use that distributive property in reverse. The 15s will come out, and what goes inside the parentheses are what's left over. So the x and the 1 with the subtraction to keep that same sign between them. And we just factored out the greatest common factor. Okay, let's try the next one. 6y squared plus 9y to the 5th. We may have to do a little bit of scratch work here. 6 and 9, 3 times 2, and 3 times 3. So I see that they have 3's in common. And then we have y squared and y to the 5th. So for our greatest common factor, we'll keep the 3 that both of them have in common. And then y squared, y 5th, we take the smaller power squared. So our greatest common factor is 3y squared. Looking at this problem now, 6y squared is 3y squared times what? What else do I need to multiply 3y squared by to get 6y squared? I need 2. And then for 9y to the 5th, if I split that into its factors of 3y squared, I need to multiply by 3 again to get 9. But y squared times y to the 3rd will give me y to the 5th. And so this first one, 6y squared, the second group, 9y to the 5th. And then I can see what do they have in common, the 3y squareds they have in common. And then inside the parentheses, I'll have a 2 plus 3y cubed. I want those leftover bits in there. And that's as far as we can factor that problem. Now let's take a look at 16. 16 is different. Now, even though your impulse might be multiply it all out, don't do that yet. See what they have in common. They both have 5x minus 2 in common, and that quantity is being multiplied by something else. We already have this problem written in the form that we need to do that reverse distributive property. We're just going to take that 5x minus 2, which is the greatest common factor in this problem, and factor it out. Then, what's left over inside the parentheses? Well, x is left over, and 7 is left over. So we're going to put those in. X plus 7, close parentheses. And now if we want to check our work, we would take this whole greatest common factor, 5x minus 2, and multiply it by x, and multiply it by 7. And that would get us the problem itself. This idea of factoring out a binomial as the greatest common factor is going to set us up for factoring trinomials in the next section. So we're going to practice with this one again. Take a look at the next problem. 2x times x plus 3 minus 5 times x plus 3. See if you can come up with the answer on your own. Taking a look at our next example, 8w to the third minus 2w squared plus 4w. Between 8, 2, and 4, they all have a common factor of 2. And then noticing the variables all are w, we take the variable with the smallest exponent. And in this case, w to the first power. So 2w. Now I'm going to do that intermediate step like we were doing before. 2w times what is going to give me 8w to the third? Well, 2 times 4 will give me 8, and I have 1w, so I need 2 more to get to w to the third. Minus 2w, again that greatest common factor, times, I have 2w squared in the original problem, so I need another w. And then 4w, I have 2w times 2 will give me 4w. Greatest common factor is 2w, so I'm going to factor that out, 2w. And then inside the parentheses goes all of the pieces that aren't highlighted, doing that distributive property in reverse, 4w squared minus w plus 2. So all of the signs are still there. And that concludes our examples in this lesson for using the distributive property in reverse to factor out greatest common factors. Greatest common factors will be the very first step in factoring polynomials. We will always look for greatest common factors first, and then we count the number of terms to determine our strategy that we will use moving forward. So the next lesson, we're going to talk about factoring by grouping when we have 4 or possibly more than 4 terms.